So I know I'll probably owe you guys a big apology for not uploading video for like a decade, of course. So I'll film my iPhone 17 right now. I'm not trying to flex, but all of my other video, it was in Virginia and Chesapeake, Virginia, and film my iPhone 11 right here in Texas. This is the first video I filmed in Texas. So hope you guys like it. And I know I'm sorry for not uploading for a very long time because I don't really got time. Because part of it, I was a little bit lazy. Keyword, little bit. Have you guys ever wondered why a squared plus b squared equals c squared? This is the most famous Pythagorean theorem, right? This theorem so that longest side, which is c, and a is like the base, but let's call it b right here. And a and b can be right here or right here, but c gotta be on the longest side, so it gotta be right here, which is the hypotenuse. Let's call a right here. But do you know why this side plus this side equal the hypotenuse squared, which is c squared? Do you know why? Well, let me explain to you why this theorem is true. So here is why this theorem is true. Well, let's calculate the area of a triangle. What's the area of a triangle? 1/2 base and height, right? 1/2 base and height. So let's draw a triangle. So this is the base, this is the height. And we don't really need the hypotenuse to calculate the area. So this is a right triangle, base and height, and divide by 2, you get the area. The reason? Very obvious, right? Let's draw a rectangle. Let's call this a base, this is a height. Half of it is basically a triangle. I know it's kind of curvy like that, but if you draw a rectangle, it'd be like this. Split in half, so you get BH. Split in half, which is half BH, which is basically a right triangle. So that's why the area of a right triangle is 1/2 BH. But we talk about why a squared plus b squared equals c squared, right? Well, here's why. So let's start by drawing 4 triangles. So this is the first one. We're gonna draw a right triangle. And the second one, we're gonna draw like this. Like this. Then it's gonna be like this. And I'm not an artist, but I'm trying my best to draw it. Then it's gonna be like this. How's it gonna be? Now, I just redraw it. This is what it actually looks like. I know this does not look like a square, but believe me, it is a square, okay? Let's just label the size. So we know the longest side is C, and we know the square also are the same. So fact check. Let's label this side B, because it's kind of like the base. So this is the base of a triangle. And this just one side of a triangle, like this. So, what is the area of these right here? What is 1/2 BH, right? 1/2 base and height. We have 4 of this, similar 4 right triangles. So, all these are just 1/2 base and height. And this is 1/2 base and height also. And the area of a big square inside here is, of course, c squared, because the area of a square is c squared, okay? Now, as you see, if you do 4 triangle like this, you leave with this one big square right here. What is one side? We need one side. If we got one side, then all sides should be the same, right? Correct. So one side is basically A plus B. So this side is A plus B. So I mean all these sides is A plus B, right? So now we're gonna write two equations. The first one is the area of this big square, which is basically A plus B squared. Of course, because A plus B, this side is A plus B as well. The area of the square is this side times this side. So it's A plus B times A plus B, which is A plus B squared, equal to what the inside is basically what's the area, right? What's the inside? It's four small right triangle. Four right triangle. This right triangle, the area is 1/2 BH. Then plus the C squared, the smaller square inside this big square. Okay, expand this, so you get A squared plus 2AB plus B squared. These cancel to a 2, so you get 2. BH is basically, BH. B is basically right here, and H is basically A, the height. So we just write BA, of course. Let's switch place, so this can match. It don't really matter, it's multiplication plus C squared. Now this or the same, so we can just subtract both sides, or you just cancel it right away. But let's subtract both sides. Cancel. So we leave it A squared plus B squared. Forgot to write B squared right here. Equal to, left with C squared, positive C squared. Aha. That's where the Pythagorean theorem came from. Very nice, right? I know. Such a nice theorem. Such a nice theorem. And yeah, that's how you basically prove the Pythagorean theorem. Draw four right triangle inside C squared. Then write two equations. First one is the outside, and the second one is the inside area. Because these and this gotta be the same, right? Because outside basically equal to inside.